All right, we're going to start chapter 2 for college algebra. We're going to do 2.1 and 2.3. We're going to skip 2.2, which is the section on circles. You'll like this first part because it's something you've done for a long time. We're talking about the rectangular coordinate system and graphing utilities. So as we move forward, our objectives are to plot points on a rectangular coordinate system, which is just the Cartesian coordinate plane that you're used to doing, x, y coordinates. Use the distance and midpoint formulas. You did those in geometry. Graph equations by plotting points. Identify x and y intercepts, and then graph equations using a graphing utility, which is basically using a graphing calculator. So, plot each point. We remember that the first value is x, the second value is y. Sometimes you have an equation that may not be x and y, it may be a and b or s and t. You usually go in alphabetical order, where this horizontal axis is your lower value of the alphabet and the vertical axis is the higher value. But this is x and y, your typical Cartesian coordinate plane. That's what you see on the right, your typical graph. So 2, 3 would be right there. You go to the right 2 and up 3. B, -4, +6, x and y. C, 0, 2.5. You kind of estimate where 2.5 is. D, -3/4. It's going to be just less than 1. Somewhere, you're going to have to estimate that, 0. Square root of 2, you might have to put that in the calculator to find out a decimal value for square root of 2, and then -2. Pi, and we know is 3.14, so you're going to have to estimate that, and -4. So some of these you may have to estimate on the graph, but hopefully you're, if you're in college algebra, you should be able to do that. Use distance and midpoint formulas. The distance formula is really just an application of the Pythagorean theorem. It's x, the second x minus the first x squared, plus the difference in the y squared. And then you take the square root of all that. Find the distance between the points -3, -4, and 3, 0. Give the exact distance and then an approximation to 2 decimal places. The exact distance is going to be the fraction. So you can label them points 1 and point 2. So x1 and y1 would go with point 1, x2, y2 with point 2. So we have 3 minus and -3, which is going to give us the plus, and 0 minus and -4, which again gives us the plus. So we have that squared, 6 squared plus 4 squared. 36 plus 16 is the square root of 52. Then you're going to have to simplify that. Okay, that's not a fraction, but it is a radical, which is an exact answer. But then go ahead and put it in the calculator, 2 times the square root of 13, and round it to 2 decimal places, 7.21. You want the distance between these 2 points. Obviously, they're decimals, so your exact answer, probably they've got this calculated, so it's going to be a reasonable decimal, and then an approximation. So again, label point 1 and 2. So we have 3.8 plus 1.2 because it's minus and negative, and then 1.5 minus 4.5. That's not changed to a plus because the 4.5 is positive. Take the difference or make the sum and then square them. And so we end up with a nice even number for this, the square root of 34, which is not an exact value, but you can put it in your calculator and get 5.83. Notice the squiggly equal signs. That means approximately equal to. Find the exact distance between the 2 points. Again, label them 1 and 2. So -3 plus 6 times the square root of 3. Remember, there's a 1 in front of that. That's -1 times the square root of 3. So, and it's like 1x and 6x, -1x and 6x. The square root of 3 doesn't change. It's just you add the coefficients in front. And then 2 times the square root of 6 minus the square root of 6. Again, there's a 1 times the square root of 6 there. So you end up with 5 times the square root of 3 plus the square root of 6 squared. You square the square root, you get a regular number. So it ends up being 5 times 3, which is 15, or 25 times 3. So let me just write that in here. Make it a little easier, I hope. So this right here, squared, is going to be 25 times 3 plus, and then square root of 6 squared is going to be 6. So there's where the 75 comes from that you see right there, in case you were wondering. And then plus 6, and that's going to be square root of 81, which is 9. So you have a nice exact answer. Okay, find the distance between 2 points. I'm going to say you probably can do this. You did it in geometry, and it shouldn't be that challenging for you. Determine if the points form the vertices of a right triangle. Well, you're going to have to plot your points, and somehow you're going to have to be able to tell if they're, I'm not sure why we have all that crazy red line, but you want to know if those lines form a right triangle, which means that 2 of them would be perpendicular to one another. And so you're going to remember, you can find that one way you can do is find the distance. Okay, so the distance between A and B, the distance between A and C, and the distance between B and C. And then you can do Pythagorean theorem. If it's a right triangle, A squared plus B squared equals C squared. Check them, and it does check out. Another way you could calculate later, when we've learned remember about slopes of lines, if they had opposite reciprocals for slopes, 2 of the lines, you could check and see that they were perpendicular to one another. So yes, that forms a right triangle. So again, check your distances between all 3 points, and then do Pythagorean theorem. The 2 squares of the 2 short ones should add up to be the square of the longer one, in case you're wondering which way to put it. All right, midpoint is like taking the average. You add your x's divided by 2, add your y's divided by 2. Pretty straightforward. So if you want the midpoint of this line segment, you would add up your x's. So negative 1.8 and plus 4.5 and divide that by 2. And then negative 3 plus negative 1 and divide that by 2. So that comes out to be 1.35 and negative 2. If you wanted to make it a fraction, you could multiply everything by 10 there. And you'd have 45 minus 18, which is 27 divided by 20. Okay. Find the midpoint of these line segments. I don't think you really need to do that, but real quickly we could set it up. It would be negative 1.5 minus 8.7 over 2 would be your x's, and then your y's would be negative 9 plus 4 over 2. And then you can calculate it out. But that's the way you would calculate that. Okay. All right, graph equations by plotting points. We tend to want to, you've had graphing calculators for so long, you tend to want to just put the equation in the graphing calculator, but sometimes you can have some errors entering the equation, and it helps to know the shape of the graph when we get into parent functions. If you remember those, that's great. If you don't, you can always plot points. And so you do this by making a table. You have your x value and your y value, and then what it's going to be as a point. So you just pick your x's, and pick easy ones. Don't pick hard ones, pick easy ones. So here we've picked 0, 1, 2, 3, and then negative 1 and negative 2. Don't pick 10, 15, whatever. Pick 0, 1, 2. and negative 1 and negative 2. So if x is 0, you've got 0 squared plus 3, which is 3. And so what you've done, you can see, you just plug in your x, whatever it is. So you just plug in your x here. So in other words, I have 0 squared plus 3, and I get 3. And here I have 1 squared plus 3, and you get 4. Here you have 2 squared plus 3, and you get 4 plus 3 is 7. 3 squared plus 3 is 9, and that's 12. Then here you might get a little, don't let your calculator lead you astray if you're using your calculator. Negative 1 squared is 1, plus 3 is going to be 4 again, and negative 2 squared is 4, plus 3 is going to be 7. Okay, so when I exit out of my thing, the writing's going to go away. But you see hopefully how we got those. And then you can plot your points. Now if you remember that the basic parent function of x squared is a parabola, and that plus 3 out on the end is an upward shift, you would already know pretty much how this would graph. All right, this is the square root function. A little harder maybe to plot the points, but again, pick easy x's. Okay. So then when you plug them in, be sure that you've got here the square root of negative 3 plus 3. First pick out the one's going to be 0, because it can't be negative. A square root can't be negative and have a real number answer. So the lowest number you're going to get is 0. So by inspection, you can say, well, a negative 3 is going to make that 0. So that's where we started at negative 3. Then we have negative 2 plus 3 is the square root of 1, which is 1. Negative 1 plus 3 is the square root of 2, and that estimates to be 1.4. Then you have 0 plus 3 is the square root of 3, which estimates to be 1.7. The square root of 1 plus 3 is 4, so that's 2. That's a nice even answer. And then the square root of 2 plus 3 is the square root of 5. And notice rounded that to 1 decimal place, mainly because you can't really graph any more accurately than that. You can't really distinguish between tenths and hundredths on a graph this size. So plug it in, get a decimal answer, put your ordered pairs there, and then you're going to plot your points. If you remember, this is grouped in with the x, so it's a plus. It's going to be a left shift. So the whole square root graph shifts like that. Okay. Graph the equation. In this case, what you want to do is get the y by itself. So you're going to have y is equal to negative x squared plus 4. Okay, so you're going to make your chart. You're going to be your x and your y, and then your pairs. Okay. So I'm going to pick easy x's. Negative 1. Now I'll go negative 2, negative 1, 0, 1, and 2. So that means this is going to be negative 2 squared plus 4. Let me make this bigger. Okay, since I'm going to calculate. Negative 2 squared plus 4. Well, that's going to be 4 plus, that's going to be, this is 4, make it negative, so that's going to end up being negative 2, 0. Okay, that's my x, y. This one is going to be negative 1 squared plus 4. So it's going to be negative 1 is my x, 1, and then make it negative. So it's negative 1 plus 4 is 3. And then 0, negative 0 squared plus 4 is just going to be 4. And then negative 1 plus 4 is going to be 3. So we have 1, 3. And negative 4 plus 4 is 0. So 2, 0. Then we go over here and we try to graph it. Okay. And we're going to go and this is x and this is y. All right, so we're at negative 2, 0 and negative 1, 3. Okay, 0, 4, 1, 3, and 2, 0. So we can see that the parabola goes like this, which if you remember your transformations, a negative flips it, which we ended up with a negative when we rewrote the equation. We ended up with this negative right here, and then it moved up 4 spaces. All right, this is an absolute value grouped in, but it's grouped in with the y, so that's unusual. So let's plot our points. This time you're going to pick your y first, because that's what you have to do something with. So we're going to pick 1, 2, 3, 4, 5, 6. At 1, we have 1 minus 4, which is negative 3, but the absolute value of negative 3 is 3. Same with 2, then 3, 4 minus 4 is 0, 5 minus 4 is 1, 6 minus 4 is 2, absolute value. All right, so the ordered pairs are listed. And so when you normally y equals an absolute value is a upward pointing v. Since it's x equals, it's a sideways pointing v. Okay. Again, we want to graph the equation by plotting points. So we're going to move the y squared over. And again, you're going to pick your y squared because it's x equals y squared minus 2. And take a minute and guess what you think this is going to look like. But pick your y's. 0, 1, 2, 3, negative 1, negative 2. Again, 0 squared minus 2 is negative 2. 1 squared minus 2 is negative 1. We're calculating what our x is based on what our y is. And this one we'll graph as a sideways parabola. We did these when we did conic sections in Algebra 2. It's been a while, and I cut it short with at least one of your classes. So we may not have really seen these too much. Okay, so this is another sideways parabola. So let's take a minute and graph it just because it's something a little different. Okay, so we're going to go here and we're going to graph this. We're going to move the y over. So you have x okay. See if I can write. Nope. Okay, x equals negative y squared plus 2. So we're going to pick our y first. So we'll pick negative 2, negative 1, 0, 1, and 2. And then we'll calculate our x. All right, so I'm going to do some calculation over here to the right. So we have negative 2 squared plus 2, which is 4, but we make that negative. So negative 4 plus 2 is going to be negative 2 that we're going to put in there for the x, okay? So we'll do our calculation here. X equals, okay? Hopefully that makes that a little better. So then we have negative 1 squared plus 2. So negative 1 squared is 1, make it negative. Negative 1 plus 2 is 1. Okay. Then we have 0, negative 0, or 0 squared plus 2 is 2. Then we have 1 squared, but it's negative, plus 2 is 1. And negative 2 squared, which is negative 4, plus 2 is negative 2. So now we're going to go over and graph it. Okay. X-axis, Y-axis. Okay, so we have negative 2, which is right here. Okay, somewhere in there. Then we have 1, negative 1. Then we have 2, zero. Oops, this first point is wrong, excuse me. Take that off. Negative 2 is over here. Okay. Then we have 2, 0, which is right here. Okay, then we have 1, 1. And then we have negative 2, positive 2. So this is a left-facing parabola. So it's kind of the same as the other one, but that negative in front flipped it over the y-axis and made it, instead of face right, face left. But if you don't know those things, doing the table makes you be able to graph it successfully, whether you realize how that relates or not. Identify x and y intercepts. Okay. Estimate the x and y intercepts from the graph. Well, you look where it crosses the x-axis is the x-intercept. Where it crosses the y-axis is the y-intercept. So the x-intercept is right about 3, 0, and the y-intercept is at 0, 3. Now notice what's important about this is where it crosses the x-axis, the y is 0, and where it crosses the y-axis, the x equals 0. So looking at this, x-intercept, we have 2 of those. We have 2 and negative 2, but we have only one y-intercept at 0, negative 4. So it's easy from a graph to see it. What about if you have an equation? Well, remember what's key. And with the x-intercept, y is 0. So you just set your y equals 0, which makes it 0 minus x squared equals 9. X squared equals negative 9. There's no real solution, which means there's no intercept. The solution is 3i, but again, if there's no real solution that doesn't cross the x-axis on the graph. What about the y-intercept? That means your x is 0. So y minus 0 squared, or y minus 0, is equal to 9, so y equals 9. So again, these are easy mathematically to do. When you're looking for the x-intercept, make the y equal 0 and solve it. When you're looking for the y-intercept, make the x equal 0 and solve it. Okay, x and y-intercepts. X-intercept, so we're going to make the y equal 0. So absolute value of 0 minus 3 plus 2. Absolute value of negative 3 is 3. So 3 plus 2 is 5. So it would be 5, 0 as a point because the x-intercept is a point. The y-intercept, you're going to make your x 0. So 0 is equal to absolute value of y minus 3. plus 2. And so absolute value of y minus 3 equals negative 2. Absolute value of anything can't be negative, so there's no solution on that piece, so there's no y-intercept. Find the x and the y-intercepts. Okay. Now this is a little trickier maybe, but still doable. X-intercept, you make your y equal 0. So you have x squared plus 9 is equal to 0 plus 3, or 3 squared over 4 equals 1. X squared plus 9/4 is equal to 1. X squared is equal to negative 5/4. Where did that come from, you may ask? Okay, 1 is the same as 4/4. So if you have then 4/4 minus 9/4, you get negative 5/4. Okay. And then cross multiply, or you can multiply by your common denominator, however you want to do it. 4x squared is equal to negative 45. X squared is equal to negative 45/4. Simplify. Well, there's no real solution because it'd be taking the square root of a negative number. So there's no x-intercept. Y-intercept, you're going to make your your x equals 0. 0 over 9 is 0. So you have y plus 3 squared equals 4. Multiplied everything by 4. So then you're going to square root both sides using square root method. Remember the plus or minus. So you have negative 3 plus or minus 2, which would be negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. Okay. Find the x and y intercepts. Okay. So the x-intercept, you're going to make your y equals 0. 0 equals x squared minus 4. Okay. So we have x squared equals 4. When I bring the 4 across, square root both sides, x equals plus or minus 2. So my two y-intercepts, x-intercepts, are at 0, or 2, 0, and negative 2, 0. Those are my two x-intercepts. The y-intercept, make your x equal 0. Y equals 0 squared minus 4. That's just 0, so y is equal to negative 4. So my point would be 0, negative 4. So that one had both. All right, graph equations using a graphing utility. Hopefully you all know how to use your graphing calculators. The stat plot, this is your stat plot. We want to be sure all of those are off when you graph. Well, this is your y equal menu, but see if you plot 1, plot 2, plot 3, if you go into your graph when you graph and get a funny number, sometimes it won't do it. Sometimes that means your stat plot is on. So you go back in second, y equals, and turn those plots off. So you enter in the equation in the graphing, into the graphing editor. Has to be y equals. If you need to change your window, you can do it. This gives you your minimum x, your maximum x. It says the scale, count by 1, same as y. Zoom 6, if you remember, takes you back to this standard graphing window. But you can change this if you want to do it, make a bigger window to look at. Or you can zoom out or zoom in. Okay? And this tells you how that window would be described if it was asking you to create a certain window. Table setup. Table, main thing that's important here is delta table. You're going to count by 1. If you want it to count by 2 or 0.1 or whatever, you can set that there. Okay. Graph on the standard viewing window. Make a table beginning at X with delta table equals 2. I'm not going to go through this. I think you know how to do it. But if you want to go through this and try to work through it, you just follow the directions and look at what your graph is doing for you. Okay, just follow these instructions, and you can look at your table to get these numbers. This tells you how to change the viewing window. You can see it's set the center off to the left. You're going to graph a cubic function that will look like that. And again, changing the window, it's an absolute value function, but you notice it put the origin towards the bottom. Okay.